In this short video, we can be looking at the following things. First of all, how you use data given in questions to justify support conclusions. These are quite often worth 4 to 6 marks, and if you know what to do with the data, it's really quite easy. Secondly, calculating percentage increase and decrease using data in tables and graphs. And then one thing that catches people out quite often is how to calculate the magnification of cells where you've got prefixes that don't match, for instance, milli and micro. And the thing that came out last year and the year before that confused students was how to calculate surface area, and that's something which comes up in biology or it could come up in chemistry for rates of reaction. So when you're using data to justify conclusions, you have to think carefully about how many times greater or less something is, not that it goes up by 30 or drops by 20. So it says a student needs a new power source. Figure 4 shows 3 different size power supplies. So you've got the high capacity, the large and the compact. Table 1 gives data about the different power sources. The student chooses the large power source. Suggest why the student chooses the large power source. So we have to use the data. So we've got to compare the compact to the large and the large to the high capacity to explain why they use the large. So let's first of all look at the number of charges. Now remember, don't say it charges up by 4 more. This large charger charges 5 times more, but the high capacity charges twice as many times as the large. So let's look at mass. The large is twice as heavy as the compact, but look at the high capacity. It's 600 divided by 200, it's 3 times heavier. So remember to talk about how much more it is in terms of doubling or tripling, not that this is 400 more. Sorry, not this is 100 more, and this is 400 more. So let's have a look at the answer I'd give. I'd first say the large power source can do 5 times as many charges than the compact one, but only weighs twice as much. So that's quite an advantage. So why didn't you choose the high capacity? Well, although the high capacity charger can give you twice the number of charges, it actually weighs 3 times as much. So that's why you could say the large one was chosen. So in this question, we've got a bar chart, and it says figure 9 shows the use of fertilizer in 4 different countries, A, B, C, and D, in 2003 and 2015. So that's the mass of fertilizer used. You can see that the light grey is the mass used in 2013, and you can compare it with how much was used in 2015 for each of these countries. A student said much more fertilizer was used in 2015 than in 2003. Is the student correct? Use the data from figure 9 to justify your answer, and it's worth 3 marks. Now again, think about how many times greater or less. So if we look at country A, 200, and first of all, it only used 20. So how many times more is that? Well, 200 divided by 20 is 10 times more. So that's a massive difference. Let's have a look at the next one, B. We've got 120 there, and it started at 70. So 120 divided by 70, this has gone up by only 1.7 times. That's not much more. Country C, you can see it went from 10 to 100, so that is 10 times more. That is much more. And look at country D, it's only gone up from 30 to 40. So that is actually 4 divided by 3 is 1.3 times. So that is hardly gone up at all. So is a student correct? Well, my answer is a student is correct for countries A and C, but not correct from B and D because they don't go up by much. And that would give you your 3 marks. So let's have a look at the next question. This one's worth 6, so needs quite a bit of detail. It says, the following table has information about different types of lamps often used in the home. So we've got a low energy, a quartz halogen, and an LED. And we've got the input power. That will be the energy that it uses, and also give an indication of how much it costs. This is the efficiency, how much of that electrical energy is converted into light rather than heat. We've got the lamp cost, so that's the cost of each lamp. We've got the lifetime hours, which is how long each bulb will last before it needs replacing. And then finally, the light quality, either blue-white or yellow-white, which is a more mellow colour. It says, use the information above to choose a type of lamp to light your bedroom. You should use all the information given in the table to justify your answer. So the key one is justifying and using the information. And it says all the information. So first of all, it doesn't really matter which one you choose as long as you justify it and you can state why you've chosen it. But in order to justify it, you really just have to compare all of these. And I'll compare each one against each of these. So let's start with the first one. This is about the input power. And you can clearly see, if we have a look, the LED uses so I would do one at a time. So if I look at this, I'm going to look at the LED. And of course, the LED uses massively less energy than the halogen. 50 divided by 4 is actually 12.5. So I could say the LED uses 12.5 times less power than the halogen lamp, and 11 divided by 4 is 2.5. So it uses 2.5 times less than the low energy, so saving on running costs. So that's the first one. Remember, you are multiplying or dividing to see how many times. So let's look at efficiency. So if we look at efficiency, I can see that the LED is nearly twice as efficient as the low energy bulb. And if I do 95 divided by 10, it's 9.5 times more efficient than the halogen bulb, so is better for the environment. So let's have a look at the next one. Well, I'm going to not use the next one yet. You'll see why in a minute. I'm going to do lifetime hours first. So if I look at the lifetime hours, you can clearly see that the LED will last 4 times longer than the low energy. But actually, if you divide 40,000 by 2,500, you get 16. So the LED lamp lasts 16 times longer than the halogen and 10 times longer than the low energy bulb. So you can see they're wanting you to compare this data. Now the next thing is the cost. And if you've spotted this, this will be very high marks. Now, although the halogen is by far the cheapest bulb, you can see the halogen is the cheapest bulb, remember you would need 16 of them for every LED. So actually 16 times 1.5 gives you £24. So that is 2.4 times more expensive than the LED overall. And let's now compare the LED with the low energy. So again, if we look at that, we needed 10 of these low energy light bulbs for just one LED. So of course the cost of those would be £25, which is 2.5 times more than the LED. And finally, we've been asked to use all the data, so I'm going to talk about the light quality. Now, I don't like blue-white that much. I find it very glaring. So I might say the advantage of the halogens is that it's a warmer light than the other two. But now I've got to make a conclusion, but the LED is clearly the best lamp to use. And you can see that because of all the other advantages. So that would give you 6 marks by comparing everything very clearly. So finally, the next skill is to be able to use and calculate percentage decrease. Now, the question here says, calculate the percentage decrease in the mean time, reaction time, when the number of hours of sleep increases from 1 hour to 8 hours. So it's the percentage decrease. So first thing is, percentages are just what has changed divided by what it was originally times 100. So of course the decrease would be this number here, 715.1 minus 238.2. So decrease is 476.3. But our original value was, it said decrease from 1 to 8 hours. So our original value was 715. So our answer is the decrease divided by original value 715, and that gives you 66.6%. The next one is to do with the percentage increase. And it says, look at the data in figure above for skin cancer. So this is the skin cancer. That's the percentage of people alive 10 years after diagnosis in 1961. And that's the percentage of people alive after 10 years after diagnosis in 2001. And it says, calculate the percentage increase in the survival rate of people diagnosed with skin cancer in 1961 compared to 2001. So it says, give your answer to 3 significant figures. Now, I would now not go and do that question. What I would do is make sure I get that significant figure mark by writing underneath where I put my answer 3SF to remind me. Now I'll go and do the question. So again, you've got to think about the scale to make sure the scale is right with the graph. So I've got 48, 2468. Here I've got 824689. So make sure you read your scales carefully. Percentage increase is the increase divided by the original value, which was this value here, times 100. So I've got 89 minus 48 divided by the original value of 48 times 100. And that would give me 85.416. Now I'll write that there, and I'd have lost my significant figure mark, but because I've written it under there, I remember to quote that. So 3 significant figures, which is 84.4, and I've got all 3 of my marks. Really important to do that so that you don't use your significant figure mark, which is easy marks in an exam. So finally, on the percentage ones, we're going to quickly check that we can do this one. So we've got concentration of carbon dioxide in parts per million. And it says calculate the percentage increase in concentration of carbon dioxide from 1975 to 2000. So first of all, I'm going to check I understand this scale. And in 50, I've got 5 squares. So each square is worth 10. So I'm just going to make sure I know that there. 1975, I've got 310.25. So I've got 325. At 2000, I'm here. So that's 350, 60, 70. So therefore, again, percentage difference, percentage increase is increase divided by original value. My increase is 370 minus the 225 divided by original value, 225, and that gives me 13.8%. So the last 2 slides I'm going to do is the first one is on cells and magnification, where you've got units that don't match. So we've got the image size of the cell is 112 millimeters, but the real length of the cell is 280 micrometers. And we have to make sure those units match. So first of all, remembering milli is 1,000th of a meter, and micro is 1,000,000th of a meter. So this is 1,000 times smaller than this. So if you're going to convert from micro to milli, you're going to have to divide by 1,000, because this is 1,000 times less than this. So what I've done is I've converted the micro 280 divided by 1,000 is actually only 0.28 millimeters. And finally, I can use the equation magnification is image size of object size, which is 120 divided by 0.28, which gives me 400. The units now match. So this final question looks at us calculating surface areas. And you could be asked this in either biology or your chemistry paper. For chemistry, it would be rates of reaction. So it says figure 3 shows 8 small cubes, 1 centimetre by 1 centimetre by 1 centimetre, and 1 large cube, 2 centimetres by 2 centimetres by 2 centimetres. And it gives you the total volume of the cubes together at 8 centimetres, and the volume of the 1 cube together is 8 centimetres. So they have the same volume. So you could have cut up this cube into 8 equal squares. And of course we know that this surface area would be larger, so increase things like the rate of reaction. But it asks you to calculate how many times bigger the surface area of all the small cubes is compared to the one big cube. So I'm going to start with the one big cube. This face, the area of this face here, will be 2 times 2, which is 4 centimetres squared. And of course, because it's identical, because it's a regular cube, we've got 1, 2, 3, 4, 5, 6 faces. So altogether, the surface area of the big cube will be 2 times 2, which is the area of one face, times the 6 faces, is 24. And of course, the surface area of each small cube is going to be 1 times 1, which is 1. And of course, you've got 6 faces, so that's going to be 6 centimetres squared. So how many times bigger is the surface area? Well, first of all, the total surface area of all of the small cubes is 6 times 8, because of 8 of them is 48 centimetres. So 48 divided by 24 is 2. So the surface area is double for the small cubes.